Hello all, this is Priyadashini working as an assistant professor in the Department of Artificial Intelligence and Data Science. Today we are going to continue with the next lecture series on deep learning. The topic for today is autoencoders. So, imagine a neural network that can shrink a massive amount of data and also it reconstructs as that of the original data as an output. Sounds crazy, right? Yes, this all happens because of these autoencoders. So from compressing the images, or if you have to denoise a sound from a video or audio, or even if you have to detect anomalies, then there is a powerful deep learning technique called autoencoders, and this deep learning technique, powerful technique, is everywhere around. So in this video, let's see how these autoencoders work. So now let's see what are autoencoders. So as we all know, autoencoders is a form of neural network. It comes under unsupervised machine learning technique. So autoencoders is similar to your principal component analysis. So here what it does is it takes the raw input data, pass it on to the encoder. From the encoder you will get a compressed information of the input data that you have sent, and then it is passed on to the decoder. The compressed information will be passed on to the decoder, and from there it reconstructs the original image. So that is why it is similar to your principal component analysis. But these autoencoders differ from principal component analysis because of the characteristics like your nonlinear transformation. That is, it introduces the nonlinearity into your network using your activation functions, and these autoencoders need not learn the different dense layers since it has many convolution layers as well. It is more efficient so that it can learn several layers within a single autoencoder itself, and the last thing that you can see is your multiple transformations. So it gives different representation as the output at the output layer. So here, let us analyze a real world application. So here we have an original dog image. When you pass on this original image to an autoencoder, it reconstructs the image like this. You can see how does it look. But when the same thing is passed on to your PCA, then the image is being reconstructed with some distortion. So that is why we take autoencoders for compressing an image or to denoise your sound from audio or video. So as I told you, autoencoders, it is a neural network and it is also an unsupervised machine learning algorithm. So here it applies backpropagation. So if you give an input, it tries to reconstruct the same as the output image. So this is the working principle of an autoencoder. Now let's see the architectural diagram of the autoencoder. So as we all know, autoencoders is an unsupervised machine learning technique, and it is also a neural network technique. So what we are going to do is we are going to pass the input data to the encoder part. So in autoencoders, you have mainly two components. One is an encoder, the other one is a decoder. So the working thing of an encoder is when you pass on the input data, it compresses the information and then it passes the information to the code, or it is also called as the bottleneck layer. That is your compressed information. The latent space information is stored over here. This latent space or the compressed information is then passed on to your decoder network. So the decoder network decodes the bottleneck or the code what has been given from the code layer. It then tries to reconstruct as that of the original input image. So this is the architectural diagram for an encoder. Now let's analyze the characteristics of an autoencoder. So the first one is it is an unsupervised technique. So as I told you, autoencoders are considered to be an unsupervised learning model because they do not have any explicit labels for training. So it comes under unsupervised machine learning technique. The second one we are going to speak is about the data specific. So when you take an autoencoder, it can able to meaningfully compress data that has been similar what has been given under training. So suppose if you take an animal data set that comprises of cat, dog, or even if you have a tiger, then it can reconstruct those animal images only. If you give like an elephant, it cannot able to reconstruct the data. That is why we call these autoencoders as data specific. The third one is it is a lossy type of thing. So when you take the output of an autoencoder, it will not be exactly the same as that of your input, since because it loses the information. Because why does this happens is from the compressed information only the autoencoders or the decoder architecture reconstructs the data. So definitely you will be having some degraded information. That is why it is lossy. So these are the characteristics of your autoencoders.